homework time. Yes, happy homework time is here again. Lesson 12. Let's start by jotting our names down at the top of the paper. Here's the dealio. I'll put my name and you put yours. And let's follow that up by taking the time to put today's date. I'll write today and you write the actual day today, where and when you are. Lesson 12, you will be happy to hear, is nothing new. It's just taking what we've learned about multiplication so far and putting it all together so that we can read, draw, write to answer word problems. Let's do it. And it tells us use the read, draw, write process to solve the following problems. Step 1, read. Let's do it. The table, there it is, shows the number of stickers of various types in Chrissy's new sticker book. Chrissy's 6 friends each own the same sticker book. Okay. Got that? So how many stickers do Chrissy and her 6 friends have all together? Well, this is kind of interesting. They're often coming back to stickers and sticker books here. You notice that? All right, well, let's take a moment and read the table as well. It's part of the question here. Type of sticker, we have flowers, smiley faces, and hearts. Number of stickers, flowers have 32, smiley faces 21, hearts have 39 stickers. Okay, so we read. Now let's draw. So Chrissy's 6 friends each own the same sticker book. Notice that. So there's Chrissy, and then we have 6 friends. And the question is, how many stickers do Chrissy and her 6 friends have all together? So a little tricky here in the wording. And if this were like a multiple choice test, I can tell you what the wrong answer would be. But let's focus on the right answer. Let's think this out. So drawing, we know that, let's kind of put these together to start with. We know we're just looking at total number of stickers is what we want to find. So over here, let's say, okay, 32 and 21 and 39. Let's put those together just so we have a single figure to work with instead of these 3 separate by category stickers. And we see, so we're just doing column addition here. We see a pattern. 9 and 1 are 10, with 2 more is 12. Regroup the 1. 1 and 3 are 4, plus 2 is 6, plus 3 is 9. Okay, so 92. So Chrissy has 92 stickers, okay? But so do each of her 6 friends. So now this is the tricky part, is how many people are we accounting for here? There's Chrissy and 6 friends. So there are 7 people. The mistake here, it would be an easy one to make, I couldn't even fault you for it, would be to say, oh, well, there are 6 people. Because it's Chrissy and her 6 friends, though, it is 7 people altogether. And so they all have the same number of stickers, okay? So we have 92. So this is Chrissy with her 92. And then she has 6 friends also with 92. So 1, 2, 3, 4, 5, and 6 friends. So now do you see Chrissy and 1, 2, 3, 4, 5, 6 friends. And they each have 92 stickers. 92 for you, 92 for you, 92 for you. You get 92, you get 92, and yes, you can have 92 too. All right. And so now all together is what we're trying to find. And so this is what we're trying to find, and we know that it's how many people? 7 times 92. All right, and let's use the standard algorithm, because ultimately that's our goal here, is to be fluent in the standard algorithm. So we're going to say 92 stickers per kid times 7 people. All right. And so here, with standard algorithm, we just put things in the right places to represent the correct place value, but we just speak of doing 7 times 2 and 7 times 9. So 7 times 2 then is, yes, 14. and we regroup the 1 in the tens place. 7 times 9, 63, and now cross it out with me. 63 plus 1 is 64. Okay, and in a very rough estimate, we can ask, okay, well, does this answer make sense? Well, this is about 100, so it should be about 7 times 100, about 700. And this is shy of 700. We're in the right neighborhood. If we got something in the thousands or just in the tens, we'd know we're way off, okay? So Chrissy and her 6 friends. Tricky, this one, huh? Right off with that, are there 6 or 7 people? Chrissy and her 6 friends have 644 stickers. Lucky girls, aren't they? Oh, I'm assuming they're all girls, it doesn't say. All right, well, look, not so bad there, eh? All right, so number 1 is done. Let's move on to number 2. Well, if you want to get a teacher going, just say the word copier. Whew. Yeah, that's like universal there. So the small copier, aren't they all? Makes 437 copies each day. The large copier makes 4 times as many copies each day as the smaller one, of course. So how many copies does the large copier make each week? See, there are a lot of different questions. You could say how many more than it, but it's one large copier copies per week. Okay. So, and we're going to assume, although we all work a 5-day work week, that we're thinking when we say week, we're going to assume we mean 7 days. So Eureka, when you revise this, you might want to specify there when we say week, are we talking about a 5-day work week or a 7-day week? We're going to go with 7 for our purposes here because I believe that's what we're looking for. So the small copier is making 437. So we read, let's draw now. Okay, so there's our small copier making its churning out 437 copies each day, probably jamming like Bob Marley, as we like to say in the teaching profession about copiers. Now the large copier is going to make 4 times as many. So we had 1, 2, 3, and 4. That'll be 4 times as many, right? And each of these constitutes 437 copies. Don't be lazy, write it out. I see you thinking about just leaving that. All right. Now what we're trying to find out altogether first, before we get to our ultimate question, is the large copier, how many copies each day it makes. And to find that, we will need to do 4 times 437. And then, of course, we'll take that product and multiply it out by 7 to find copies per week. And if, in case, little advanced note here, you're thinking, whoa, couldn't I just do 11 times 437? Yes, you could. It's just that we haven't yet taught you the 2-digit factor there yet. So we'll do it in 2 steps instead. So 437 small copier copies times 4 will give us the large copier copies. And so again, we're doing standard algorithm, so we're just talking about 4 times 7, 4 times 3, 4 times 4 with the regrouping. So 4 times 7 is, yes, 28. Regroup that 2, and 4 times 3, 12. Cross it out with me. 12 plus 2 is 14. Place the 4, regroup the 1 in the tens place. 4 times 4, 16, plus 1 is 17. So 1,748. That makes sense because this would be about 400 times 4 is 1,600. We're in the right neighborhood. It's not crazy. All right, and so if we take this 1,748 and multiply it out by the number of days in a week, we will get the number of copies in a week. And again, we're going to assume by 1 week, they're talking about 7 days. Maybe it's that kind of school. or office. It doesn't specify if it's a school or what. So it's times 7. And we'll use standard algorithm again on this one. So the numbers are a little bigger, so we have to kind of go slowly and pay attention here. So 7 times 8. Yes, and again, I'm assuming you know your multiplication fact. So it's 56. We place that 6, regroup the 5 in the tens place. 7 times 4, 28. Cross it out with me. 28 plus 5. Got it. 33. Good. And regroup the 3 in the hundreds place. Now 7 times 7. 49. Cross it out with me. 49 plus 3. 52. Good. Regroup that 5. So now 7 times 1. 7. Cross it out with me. 7 plus 5. You know that. 12. Great. And if you're wondering, does this answer, put our comment, 12,236, does this make sense? Rough estimate, this is round up to nearest thousand is 2,000 times 7 would be 14,000s. We're at 12,000. We're in the right neighborhood, okay? And it's a beautiful day in the neighborhood. So how many copies does a large copier make each week? The large copier, when it's not broken, told you, don't get teachers started on copiers. The large copier makes 12,236 copies each week. So we read, we drew, we wrote, we came, we saw, we conquered, and on to number 3. And in number 3, we take a little trip to the Boy Scouts. Remember, several lessons ago, we had Girl Scouts selling Girl Scout cookies. Now we have Boy Scouts selling chocolate bars. I thought they sold popcorn, but hey, what do I know? So Jared, good little Boy Scout he is, sold 194 Boy Scout, it's a tongue twister, 194 Boy Scout chocolate bars. Good. Matthew sold 3 times as many as Jared. Gary sold 297 fewer than Matthew. Our question simply is, how many bars did Gary sell? So we know we have comparison going on here. This many more, this many times more, this many less, this many fewer. So we know we are going to draw 3 separate tapes here, okay, because we're not talking about part of a whole. We're talking about 3 separate Boy Scouts. So Jared, he's got 194 sales under his belt, his Boy Scout buckle belt. So now Matthew, however, is going to be Jared times 3. So 1, and then 2, and then 3. And these are each, let's just write them in, 194, 194, 194. I apologize, that 4 does not look like a 4. Okay, and let's go ahead and just take a moment, because it'll save us time down the line. We know for Matthew that the total for him will be 3 times 194. Now Gary, good old Gary boy, he sold 297 fewer than Matthew, and just to kind of approximate that, I can see like, oh, well, that's 194, so going backwards, 297 is going to be yay. So Gary, and what we know here is the difference between them. We know that this, and I can put a little dotted line here if I want to be clear on what I'm talking about exactly. That is 297 fewer than Matthew. And what we're trying to find is how many bars Gary sold. Okay, so let's do that. So first we have to find Matthew, obviously, before we can subtract the 297 from it. And we already wrote out what our equation is for that. So it's 194 times 3. And we, of course, will go on using the standard algorithm for this. So it'll be 3 times 4, 3 times 9, 3 times 1 with the regrouping as needed. So 3 times 4 is 12. Regroup that 1 in the tens place. 3 times 9, 27. Cross it out with me. Plus 1 is 28. Place the 8. Regroup the 2 in the hundreds place. 3 times 1 is 3. Plus 2 is 5. And that makes sense. That's about 600. There's about 200 times 3, which would be 600, so it makes sense. And now Gary is 297 less than that, fewer than Matthew. So if we take Matthew's, stupendous job, by the way, Matthew, 582 chocolate bar sales, and subtract Gary's shortfall, bad Gary, of 297. No, he tried. Good job, Gary. And now we subtract these, we will get the difference between them, which will give us Gary's number. And notice, like, your head is shaking. Your brain trembles and quivers because here we are, we're doing subtraction with regrouping. We haven't done this like in lessons upon lessons, but here we go. We cannot take 7 from 2. So we'll need to decompose that 8 tens. You remember all this? Yeah, the 8 tens. We will leave 7 tens where they are. Bring 1 10 over to the ones place as 10 ones. With the 2 ones already there is 12 ones. Is this all familiar? Yeah, 12 ones minus 7 ones leaves 5 ones. Yes. And once again here we cannot subtract 9 from 7. So we'll decompose that 5 in the hundreds place. We'll leave 4 hundreds where they are. Bring 100 over to the tens place as 10 tens, joined with the 7 tens already present in the tens place, gives us 17 tens. Minus 9 tens is, yes, 8 in the tens place. And then 4 minus 2 in the hundreds place leaves 2. And this makes sense. It's about 600 minus 300 is about 300. See how that quick rounding estimating is very useful? So it makes sense. Gary sold 285. See, he didn't do so poorly. That's pretty good. That's a lot of chocolate, man. People are going to get sick. All right, so Gary, I assume it wasn't sold all to one person. Gary sold 285 chocolate bars. Nice job, Garski. All right, and we'll go on to number 4, which has 2 parts, A and B. Let's start with 4A. Well, 4A is really simple. You're going to be like, are we done already? 4Bs will require a bit more of us, though. So what we're going to do here is just write an equation. So we're just dealing with the numbers. They're giving us, as you see this tape diagram, write an equation that would allow someone to find the value of M. And so we could see from the bracket here that M is this tape plus this tape together. So it's the 2 of them. All right, so we know that we're going to be adding those. So it'll be 973 plus, well, now when we look at this, it's 723 meters 3 times, I just said times. And so let's put that in parentheses to show that we're doing the 723 3 times. And so I'll write it as, you can write it in either order, but I'll write it as 3 times 723. And that, of course, when we put it together, 973 and 3 times the 723, we will get M. That's it. I told you it was easy. All right, but now let's go on to 4B, where, well, there's more to do. Let's take a look. All right, so you have it right above there, but I copied over the tape diagram in our equation here. So you see we have to write our own word problem to correspond to the tape diagram and then solve. Okay, so, you know, I like running, so we're talking about linear distance here and meters. And so we could have somebody, one person runs a course of 973 meters, and another person does a 723 meter course 3 times. He does 3 laps, right? And we want to find out how much the 2 people run together, or maybe it's the same person who does you know, different amounts. I'm going to do 2 different people just to keep it clear. Okay, and so let's give them names. What shall we call them? Let's have Bob. Okay, so Bob is going to run the 973 meters. Bob ran a 973 meter loop. And, oh, let's call his friend Marley. Oh, that's cute, huh? And Marley ran a 723 meter track three times. So how far did they run all together? And that would be our M. Okay, and you could do anything with this. Don't copy what I wrote. Jeez, it's not even that good, really. You know, it could be like one person rolled a donut down a 973 meter hill, and the other person, I mean, like, come up with something fun and interesting. Okay, so now we have to and then solve. So let's do the solution, which we already mapped out here in our equation previously. So we know first, because it's in parentheses, we'll do this 723 times 3, and of course we are using the standard algorithm, my friends. So it'll be 3 times 3, 3 times 2, 3 times 7, with regrouping as needed, which it really isn't any. So 3 times 3 is, you got it, 9. 3 times 2, 6. And 3 times 7 is 21. So 2,169. That makes sense because it's about 700 times 3 would be 2100s. 2100, 2,100. Good. And our final answer will be around 3,100, right? Because we're going to add about 1,000 to it. So let's do that to get our M. We're going to take, that's Marley's distance in meters. So now we'll take the 2,169 and add to it Bob's distance of 973. There we go. And then we'll get a total, that M. So 9 plus, remember doing addition here, 9 plus 3, is 12. We'll place a 2, regroup the 1. I see I have 7 and 7 make 14. Good. Regroup the 1. I see a pattern here. I have a 9 and 1 make 10, and 1 more is 11. Place the 1, regroup the 1, and 1 and 2 make 3. And that conforms to my estimate. And so now we can write a solution statement. So Bob and Marley ran 3,142 meters all together. Nice job, Bob Marley. All right, well, you've done it yet again. This homework time is complete. Great job. And I will see you again next time. It is homework time.